Hey all, this wee video is like some of the other ones that I've uploaded in the past, this course shell, where you can stop this, you can rewind it, you can download it, you can do whatever you need to do, because I'll go through it kind of quickly because I don't want to spend a really long time narrating um, parts of this video and making it an excessively long presentation. But you just saw an image there of a list of characteristics like eyes, eye shape, eyebrows, and these were traits, alleles. They were a set of letters that were by that characteristic. And I'm going to talk a little bit about phenotypes and genotypes. Genotypes refers to the genes. It refers to those genes that you inherit, that 23 inherited from your dad and 23 that you inherit from your mother to make your 46 chromosomes. Those genes make you who you are. So the genotype, think genes. Those are those traits. They're usually a set of letters that represent a trait. So if you have blue eyes or brown eyes, you might see a set of letters like B's, and they might be a big B, or big B, little b. And we're going to talk about that a little in terms of what that means when we look at traits and when they're together. There's also phenotypes, and think of physical. That's the physical characteristics. So you might have a set of traits, and it might be represented by the letters big B for brown eyes. And the physical characteristic or the physical representation of that trait is going to be brown eyes. So we're going to look at genotypes and phenotypes. We'll do some Punnett squares, and we'll try to connect them all together. So think pheno is physical, those characteristics that are expressed due to a set of genes that are present in an organism. So if you have had some classes in maybe, prior to this one, or maybe in high school, hopefully some of these terms seem familiar, and I don't want to overwhelm you, so do pause this if you need to. So when we look at phenotypes, we look at things like dominant traits or a set of dominant and trait. The dominant trait is going to be expressed or showed up. If you have a recessive trait, it's going to be hidden when it is in the presence of a dominant trait. So if you have a big letter and a little letter together, it is the big letter or the dominant trait that will show up. Now, recessive traits show up if you have two of them. So if you get a recessive trait from your mom and a recessive trait from your dad, then that trait is going to be expressed. Now, lots of terms, right? Heterozygous and homozygous. When you see the word hetero, it means different. And we think zygous, like a zygote, when you have sperm and egg together and they form a zygote. So hetero means different. And when you see homo, it means the same. And I know these terms show up in other aspects of terms and terminology. So if you have two letters, two traits, that are representing a characteristic in an organism, and you have a big letter and a little letter, that's a heterozygous set of traits. If you have the same traits, homozygous, like maybe a big letter and another big letter, or a small letter and a small letter together, they're the same. They are homozygous traits. And I'll show you some examples of these, so hopefully it'll all kind of come together and make a little bit more sense. Now, here's another little representation of some traits. Here's eyes, straight, slanted upward, almond shape, round shaped, etc. And you see like little letters underneath each set of those eyes. Like the shape eyes have AA, you have a big A, big A, big A, little A, little A, little A. This is just a little example of a set of traits. Why is it a set? Why is it a pair? Because one comes from your mom and one comes from your dad. So then you have two. You have a set, you have a pair. This is just a sheet that I often use when I physically have students in a class, and I'm actually going to show you pieces of this, maybe in hopes of giving you some examples. So they're just like little genetics practice problems where we look at genotype, phenotype, heterozygous, homozygous, and so you kind of see that list there where you've got sets of letters, maybe both are capital, maybe one's a capital, one's a lowercase, maybe you have two lowercase. So I have like my little pen pointing at that first one where it has capital A, or uppercase A, uppercase A. They are homozygous. Then underneath it is an uppercase and a lowercase letter, so that is heterozygous. Now, when we think of genotypes, you have a combination of letters and it represents characteristics. So you have a genotype, the genes, and it represents the phenotypes, the physical characteristics. So, for example, right here, you have two letters, those traits, those alleles, a big P and a big P. That means that flower is going to be purple. Or right here's an example where you have a big B and a big B. That means you're going to have brown eyes. Or a big B with a little b. Remember that big B is hiding that little b. That little bottom set where you have blue eyes, those are two recessive traits, little b, where the blue eyes are going to show up. Here, I've kind of just reversed it where I have some blanks and I actually give the physical characteristics, straight hair and curly hair, and what genotypes or sets of letters would represent that. So, for example, straight hair is dominant, so it's going to have a big letter, and then the small letters are recessive. And this is just more examples where you have dominant, recessive. You see that terminology where dominant is the big letter, recessive is a little letter. Recessive is going to show up if there's two small letters together. Now, when we think about this, and if you've ever heard the term Punnett square, this right here is a Punnett square. And those R's, big R, times little r, that just means that each set of R's represents a parent, and that X, that means times each other. Like the parents get together and they have offspring. And we look at the chances of them having dominant or recessive trait for their kids. So this Punnett square, I've set it up where I've got the letters at the top and the side. So it's kind of like a math kind of problem where you're combining things. This is how it would be filled out, where I've got that big R coming down to the box, the little r coming over. I'm taking the little r and the little r. So if you kind of look at that, if it kind of makes sense how I fill that out, I just brought those letters down and filled in those boxes. And now I'm going to look at the combination of these. I have a box that has a big R, little r, another box with a big R, little r, a couple of boxes with two little r's. So if you have to go back and look at that box, you'll notice there were no boxes where there were two dominants. There are no homozygous dominants. There were a couple boxes, though, 2 out of the 4, that had a big R and a little r. So half of them were big R, little r. And then the other half of the boxes had 2 little r's. So here's another one where I have a big R and a little r, uppercase and lowercase. And the other parent is big R, little r. So I'm going to fill out that box. So if you look at that real quick, if you want to pause this and think, well, what's that going to look like? How's it going to be filled out? I'm going to bring down a big R, bring over a little r, and that's what you're going to end up with. And I've got 4 boxes. One box has a big R. 2 boxes have a big R, little r, and one of those 4 boxes has a little r, lowercase. And I'm going to go through that same process I did with that previous Punnett square, and if you need to stop at any point. So I've got 4 boxes. 1 out of 4 is 25%, right? Kind of like 4 quarters. 1 quarter out of $1 is 25 cents. 2 out of 4 is 50. 3 out of 4 is 75. 4 out of 4 is 100. So I'm going to think about that in terms of how many boxes have those combinations. So I have 1 box, 1 out of 4, that has big R. I have 2 boxes, or 50%, that have big R, little r. I had 1 box that had little r. That was 1 out of 4, or 25%. So if I want to see how many of those boxes had a big R, how many had a dominant trait, a big R means it's going to be round. Well, I had big R, a fourth of them, and then I had big R, little r, 1/2. Well, 25% and 50% is 75%. And then that little r, of course, is the same because it was just one of the 4 boxes. I hope this kind of makes sense. For most of you, it will be familiar. If it's a little overwhelming, I try to find a nice link, or I can actually record myself filling these out instead of just uploading images. But just hang in there and go through this and see if it makes sense. We'll review it again. But I'm going to stop at this point because I have reached an almost 10-minute video and I didn't want this to be long.